So to find the least common denominator, we want the smallest number that's a multiple of all the denominators. Okay, so that's called the least common denominator. So it's the smallest number that the denominators all go into or all um, are factors of. Okay, so here, if we're trying to find the least common denominator between 11/30ths and 7/24ths, first we'd want to take the denominators and find the prime factorization. All right, so 24, the prime factorization would be 2 to the third power times 3. And for 30, it'd be 2 times 3 times 5. Okay, so we got it down to prime numbers. So now what we want is we want all these numbers represented. We want all these represented and all these represented, but not in excess, right? We don't want any extras. Like if we could just multiply these and these together, and that would get us a common denominator, but it wouldn't give us the least common denominator. We'd have some waste there, right? So what we want to do is kind of like a GCF, we want to match things up, but we want to take the one with the higher exponent when we see things match up instead of the lowest exponent. Okay, so if I have 2 cubed, I need all 3 of those 2's, but I don't need this one as well, right? Because that one's accounted for. So I take 2 cubed, and then this one, I already have a 2 in there, right? So I don't need that 2. And then I need a 3. So I have the 3 over here. They're both 3 to the first power, but I don't need this one anymore because I have it over here. Okay. Now that I have everything in 24 represented, now I need to make sure, okay, is 30 fully represented? And I'm missing this 5, so I want to make sure I put a 5 there. Okay. So now I have all the factors of 30 included here and all the factors of 24 included here, right? And so that's how you get the least common denominator or least common multiple. Okay. All right. And then once you get those values, you just multiply them together. So 2 cubed is 8. 8 times 3 is 24. 24 times 5 is 120. All right, so when we're dealing with polynomials, what we want to do is we want to factor each denominator completely. Okay, so factor completely, right? We've been practicing this for, all of chapter 5 and now into chapter 6. So this, like I said, is something that you'll do again and again for various reasons. And so we want to factor each denominator completely. Then we want to use exponent notation for each repeated factor. Okay, and that's not super crucial, but it's recommended. Number 2, write the product of all the different factors that appear in the denominator. Okay, so just like we did with the 30 and the 24, we want to write a product of all the different factors. So we want to make sure that all of them appear, and then that would be the that'll kind of tell us what factors need to be included in the least common denominator. And so on each factor, we want to use the highest power, like we talked about with the 2 cubed and the 2 of any of the denominators. Okay, and we'll collect all the factors. If there are any repeats, we want to get the one with the highest power, and then we just multiply all those together, and that becomes our least common denominator. All right, so here's some practice to find least common denominators. So here we have 20 and 50, right? So I'm going to do the prime factorization of each. So I'm going to do a little factor tree. 2 times 10, 2 times 5, 50, 5 times 10, 2 times 5, right? So I can rewrite those as 2 squared times 5 and 2 times 5 squared, right? So for the least common denominator, I have a 2 that matches up here. I want to take the one with the highest exponent. So it's going to be 2 squared. Same thing with the 5s, right? I have a 5 here and a 5 here. I want to take the one with the highest exponent. So it's going to be 5 squared. So the LCD will be 2 squared times 5 squared, which is 4 times 25, which is 100, right? Okay. All right, let's check out number 7. So number 7, we have variables involved. No big deal though, right? It might be even easier that way because you don't have to break down the numbers. The variables are already broken down, right? And so I'm going to see what I have in common. I have x here, x here, x here. I want to take the one with the highest exponent. So it's going to be x to the 5th. Then I have some y's. I have a y here, y here, y here. Take the one with the highest exponent. So it'll be y squared. Okay. And then let's see, we have z's. One here, and one here. I want to take the one with the highest exponent. So it'll be z to the 5th. Okay. Actually, I don't need that multiplication symbol there. We can just write all that together next to each other, and can't simplify anymore, so that's our LCD. Okay, so those last ones were monomials, right? So what do we do if we have a polynomial? So what we're going to do is we're going to factor, right? Just like we did before. So we're going to factor completely. And so here I have a simple quadratic, right? So I want to factor that. So it'll be A, looking for numbers I can multiply to get 6 that I can add to get 5. So that's 2 and 3. This tells me the sign of the bigger number, so the 3 is positive. And since this is positive, that means our signs are the same, right? Now, a squared plus 4a plus 4, that's actually a perfect square trinomial, right? A squared is a perfect square, 4 is a perfect square, and if we square root them, we get a and 2, respectively. If we multiply those together, we get 2a. If we double it, we get 4a, right? And so we can just take the square root of a squared and put it here. Then we can take the square root of 4, put it here, right? That 4. And then we just need to take this sign, and that tells us what goes in the middle, okay? So now let's find our LCD now that we have these factored. So we have a common a plus 2 here. We want to take the one with the highest exponent. So it's going to be a plus 2 squared. Then we have an a plus 3. So we definitely need that as well. Okay, we don't have anything that matches it, but we still need it because we need everything represented. So that would be our LCD in that case. All right, so the same principles with constants as with monomials, as with variables, as with polynomials, is we want to factor them, and once we identify the factors, we want to make sure that all the factors are represented, but not in excess. Okay, so we want everything represented to the most or to the max, but without any repeats. Okay, we don't need this because that's already represented in this. Okay.